So, who's next?
Dr. A.K. Vidyarthi.
Yeah.
Manu Bhatnagar, Dr. Manu Bhatnagar can speak later on.
Yes.
So next is Dr. A.K. Vidyarthi from Central Pollution Control Board. If not, then we have third speaker in sequence, Engineer Ram Balak Singh, CPCB Lucknow. No.
I think they are still there in the plenary session.
Maybe.
So maybe next one is Engineer Kalika Singh, UP Pollution Control Board. Engineer Kalika Singh. Okay, so there is no one defining the challenges. So should we go to technological options?
I think we can go.
So Professor H.S. Shankar.
Sir, I think Dr. Manu Bhatnagar has joined back. So
okay, yeah, maybe then. Dr. Manu Bhatnagar, have you joined?
Allow me to speak after a few minutes, just trying to see should I speak it out.
Dr. Manu Bhatnagar, sorry, you are not fully audible. We can see you, you are connected, but it seems some challenge at your end.
Maybe if you switch off the video, things would be better. The bandwidth was...
Just switch off. Now, am I audible?
Yes,
yeah,
now better.
Okay, so basically, we carried out a study on the Assi River.
No, this is sorry, Dr. Bhatnagar, there is a drop in your voice. We are not able to hear you properly.
Reset the connection and join.
You can reconnect, you can rejoin.
Right. Yes, sir. ये जरा मतलब आपका कनेक्शन से किया है इससे, ठीक है? वो मतलब उससे या तो उसमें स्ट्रेंथ नहीं है, आप क्रोम में जाना होगा।
यस सर,
वो ये है उसमें
सर ये आईपी एड्रेस।
अब तो कल आईपी एड्रेस वगैरह तो हमने कोई डाला नहीं था।
नहीं सर, आ रहा था, कभी खुला था।
अब बताइए यहाँ डालूं?
हाँ सर,
एक मिनट, ये पूरी तरह खुले तो ये देखिए कुछ बता रहा है बेजमा इंटरनेट एक्सेस।
कनेक्टेड है सर,
है तो मगर फिर मतलब उसमें कोई दमदार वो मतलब उसमें कनेक्शन में मतलब इतना वो अच्छा वो आ नहीं रहा है।
Sir, your voice is very much clear now.
Okay, so let me just speak out the points which I want to raise by way of challenges which I saw when we carried out a pilot project in January and February 2017. So basically the first thing is so the first thing is that we found that there's a lot of solid waste disposal which is happening in the Assi Nadi or Assi Nala, you can prefer the name. But this is frankly a municipal corporation problem. If they don't do their task properly, then a whole lot of solid waste, including dead carcasses, are to be found in the Assi Nala. And this it prevents any kind of actual cleaning experience, or pilot project or any other form of treatment. It is rendered very difficult. The second thing is that the velocity of the flow is very high. Uh, Now, if you see the average gradient in the 3.5 kilometer stretch, which is still visible, it is 1 is to 200. In the last 2 kilometers, the gradient becomes 1 is to 130. In the last half kilometer, the gradient becomes 1 is to 30. In last 300 meters, the gradient is 1 is to 20, and in the last 100 meters, the gradient is 1 is to 13. Now, with this kind of gradient, the speed of flow is very high, and you know that unless there is adequate retention time, it's difficult to carry out any form of treatment.
Sorry to interrupt, sir. Sir, are you showing some presentation?
I'm finding it difficult with the kind of connection I have over here, so I'll just see if I can show it a little later.
Okay, okay, sir. Sorry
Okay.
for interruption. Yeah, thank you.
So, so two challenges I have mentioned. Then there's a third challenge, and there's a lot of sludge deposition also in the Assi Nala. And that unless that is removed, I don't think many other forms of cleaning activity can really work out. A third thing is that we measured the flow, and there's a V notch installed close to the end, and for 2 days we actually measured the flow over 24 hours on each day. Now, if I had been able to show you the slide, you would find that in the V hours, that is from 12 o'clock at night till 4 o'clock in the morning. At other hours, the flow is 70 to 80, 85 MLD. That was in 2017. But even in these 4 hours of the night, that is from 12 midnight to 4 a.m. in the morning, when you would expect that, normally there would be nil flow, there is actually 35 MLD of flow. And what does that mean? That means that there is a natural base flow from groundwater which is feeding the Assi Nala. So that is actually helping to dilute the pollutants which are coming in by way of sewage. So these are some of the findings which we had at that time, and I thought I'll just place this in front, on the table so that it could just kick off the discussion on Assi Nala. Thank you.
Thank you, sir. So, Dr. Vidyarthi, is Engineer Balak Singh or Engineer Kalika Singh there? Okay, then we go to Professor Shankar, IIT Madras.
IIT Bombay. Vivek, can you put on the slide, please?
Yes, thank you.
Can you put up the slide, Vivek? Okay, the slide is taking time. Let me start. Can you all hear me?
Yes,
Can you
yes,
all hear me?
Yes, you are very
Good morning.
Go ahead.
Good morning, all of you. Good morning, all of you. It's such a pleasure speaking to you from a great distance. And Professor P.K. Singh has already summarized very beautifully. And Professor Bhatnagar has more to say on Assi River. My submission to this august audience is that, Varanasi is probably the oldest city in civilization and the center of intellectual activity. And the best thing would be to actually pump water from Ganga into Assi and Varuna so that the river starts to flow again, because it is a non-consumptive use. So there is no objections from anybody. And once the river starts to flow, it is my perception that Varanasi intellectual activity will come alive. So this is my basic suggestion, essentially creating something like 1,200 crores of money for the restoration of Varuna and Assi to be given to the Jal Nigams. And most of the problem will actually get resolved once we do this. Now, having said this, there are a few important points that we must recognize from a technology point of view. That is, that really speaking, a river runs because the source has a huge amount of water because of the forestry at source. And much of this forestry has disappeared over the last hundreds of years. Once it is restored, these problems of river having less water will also disappear. I have seen this in many places, particularly in Arvari, where my friend Mr. Rajendra Singh is working. So I've seen this river getting revived. Therefore, reviving Aruna Assi is not a big problem once we address this issue. So my fundamental submission is that we try and create through the Jal Nigam funds for pumping water from Ganga into Varuna and Assi. Having said this, there are some points Professor from INTACH has said about a lot of waste being thrown into the river. I mean, these are problems of corporation is well taken. And to the extent that we can resolve this by talking with them, yes, and whatever arrangements that are required to be provided. I think all these are going on. Varanasi is under a great amount of work is going on, and the quantity of waste going into these rivers have come down significantly over the years. But having said this, I'd like to briefly point out to you that we have a very interesting, what I call as natural technology, which has been working very well throughout this country. And we have done close to about 200 million liters of work in different parts of the country. And many religious shrines like Pandharpur and all that, also our plants are working and extremely well. What we create is a natural garden using a media which has the capacity to absorb and the reaction rates that are required for this reactions to occur. Vivek, can you put up the slide? Vivek?
It's already there, sir.
Slides, I'm not able to see. Okay, doesn't matter. Somehow I'm not able to see this. I'm able to see now. Okay, okay. Can you put up that mathematics, please, Vivek? For a minute, just that mathematics. I'm not able to see the differential equation because that says everything about what needs to be done. Okay, okay. Ladies and gentlemen, what I'm trying to put across to you. Hello? Yeah. Thank you, Vivek. See, what I'm trying to put across to you is that we have been looking at, waste treatment, solids and liquids and gases and so on for the last 30 years at IIT Bombay. I've retired from IIT now. Now, we represent this whole process by a form of a differential equation, which you can see. It's a partial differential equation in the sense that you can write the same thing for all the three dimensions, whatever may be important. In many of these cases, our experiments suggest that one-dimensional flow may be adequate to describe the process. So what we have done over the years is actually determine the parameters of this differential equation. So we know exactly what is the value of D that characterizes the media that is available in various parts of the country. And therefore, we are able to tell precisely what needs to be done from the point of view of design. So as you can see from here, it has another unknown parameter, which is called the reaction rate. So these reaction rates that we have been able to achieve, I'm very pleased to say, over the last 25, 30 years, we have been able to increase the reaction rate by orders of magnitude, close to 100 times from what we got in 1990. In other words, what we have is now a culture and a catalyst, which is able to enhance the rate of chemical reaction that is required to process the waste material. It can be solid, it can be liquid, it can be gas. In the case of Assi, maybe we are looking mostly at liquid because the solids can be removed in principle by the corporation, so that only the liquid comes in, which can be treated appropriately. Can you show one more picture of this, Vivek? No, backwards. Just backwards, please. Backwards. You showed just now. Yeah. Thanks a lot. See, what we have in this whole technology we call as CAMUS SBT. CAMUS means Continuous Multi-Stage Advanced System of Soil Biotechnology. So essentially what we are using here is the biochemistry of soil. The biochemistry of soil appropriately integrated, for which we know how to do it because we have been doing it for the last number of years, that we have a bioreactor into which we put a media. The media is so chosen, so it has the ability to support the biology. The biology that we use nowadays is primarily acarine culture, which is so small that it can penetrate even 1 micron pore dimensions of the media. Okay, so the media is what we locally use. Most of the time, the media that we are using in Ganga Basin is only broken bricks because it is abundant, easily available, relatively cheap. Okay, so once you put this material and then you pump the water suitably, appropriately distributed and so on, for which we have a good distributed design. When the water percolates, the most important point here is that the pore space in the media is so large that the redox potential at any point that you will measure is close to 800 to 900 millivolts, showing that the oxygen availability right across the 4 meters of depth is extremely large and there is no oxygen deficiency at all. That is our experience of last many years. So you have an aerobic technology. I heard yesterday from one of the eminent speakers that CAMUS SBT and Phytorid are the same. But I'd like to clarify to all of you that Phytorid is actually a submerged system. It's entirely submerged in water, where the oxygen diffusion coefficients are of the order of 10⁻⁹ meters squared per second. While here we are looking at oxygen diffusion coefficient of the order of 10⁻⁴ meters squared per second. Or in other words, Phytorid and CAMUS SBT are entirely different technologies. They look alike. When you look at a plant, they seem to look alike, but the fundamentals that are captured in the process are entirely different. And consequently, the rate of chemical reaction that we're able to achieve in CAMUS SBT is orders of magnitude higher than other technologies. If you compare with CAMUS SBT and HBR, for example, the space requirement is actually less than HBR because we do not generate sludge as it happens in HBR. In other words, you need to create space for sludge disposal in HBR, which is not the case in CAMUS SBT. Cut the long story short, what I'd like to present to you, sir, is to be able to revive Varuna and Assi, all that we require to provide about 1,200 crores, both for both the rivers to Jal Nigam and IIT BHU in association with us and my team and Jal Nigam. Within 12 months, I promise this revival of both the rivers can be achieved while we continue to work at the source to improve the source of water at the river source about 100 kilometers away and so on. Okay, this is my humble submission, and I request this house to recommend to the government to provide 1,200 crores to the Jal Nigam so that this problem of Varuna and Assi can be revived within 12 months so that civilization has known Varuna and Assi as the center of civilization can be restored. Thank you very much.
Thank you, sir.
Thank you.
So since I am the...
Hello?
Yes,
Hello,
yes.
yeah.
Thank you, Professor Shankar. I was supposed to introduce Professor Raghav Verma because he is the next speaker.
Okay, no problem. And thank you so much for this opportunity.
Thank you very much. So we would now like to listen Professor Raghav Verma from IIT Mumbai on application of an advanced instrumental. So Professor Verma.
Can you see my screen?
Yes, it is visible.
Okay, so let me begin at the beginning. And people have been talking about, Dr. Shanti Sarup Bhatnagar talking about Kashi and this thing. But Kashi is revered worldwide. And I would just like to quote a quote from Mark Twain, an American, that Banaras is older than history, older than tradition, older even than the legend. and looks twice as old as all of them put together. On a personal front, at IIT Bombay, I had once invited a senior professor from Caltech, and he had a whole itinerary which excluded Varanasi. So I personally took care of his stay at Varanasi, and then he said he has visited all the old cities, Rome, Egypt, everywhere. And since the time he has come to Varanasi, his eyes has just been open. He's just trying to absorb the culture. So this talk is about a very small attempt to restore the old glory of Banarasi. Banarasi is the Pali form of Banaras as we now know. So what do we are proposing is develop the first of its kind high intensity superconducting electron accelerator with the help of scientists from Japan, which will fit into narrow bylanes of Varanasi to transform the landscape. And these are various pictures of Assi. And though I am from IIT Bombay, but hu chora Ganga kinare wala hi. So it's in my interest, as he said, if we don't do it, as Professor Singh said in the opening remarks today, who will do it? Now, pollution in Ganges, as Dr. Bhatnagar also said, there is these carcasses, cremation, the nalas flowing in, industrial waste, human and cattle excreta, and fecal matter. One thing that we have not yet been tackling is the level of arsenic which has seeped into the groundwater in all of Indo-Gangetic plain. I believe we do have a system which would take care of all this. And this is some of the, data from Varanasi, where the fecal coliform, this should be as less as possible, but it is 88,000 per 100 ml in Varanasi. It doesn't beat any of the norms of NGT. What we are still unaware, because the level of problem is at a much baser level, but there are contaminants of an emerging concern which have found their way even in the purest water in the world, which is in Switzerland or France. And these are called contaminants of emerging concern. We have not bothered to look at it. And they are, generated by antibiotics, detergent, metabolites, disinfection byproducts, which have been available in plenty right now, explosives, pharmaceuticals, personal care products, solvents, you name them and you have it, steroids, reproductive. And we have not yet bothered, because if you see the state of Assi River, these are next class or an order of magnitude less, and still they are very harmful. And so we need to have a treatment which would take care of all this. So removal of harmful impurities such as COD, BOD, remove color, odor, TN, TP. There was this nutrient loading, disinfect. This is the major problem of the River Ganga, where as I also, when I performed the last rites of my father at Manikarnika, I took a dip, and they would render you antibiotic resistance. I did develop that. So we need a technique which is compact, efficient, and can treat large amount of water in a cost-effective way. Dr. Bhatnagar mentioned in his opening remarks that the velocity is very high. Now to change the gradient would be very important, very difficult. There are solid waste. You have to take care of that. There is sludge deposition that has to be taken care of, and the flow also is very high. I believe what I read was 60 MLD is what Assi discharges in Ganga at Assi Ghat. And the Prime Minister has spent substantial amount of his MP's fund to beautify Assi Ghat. There are now yoga sessions, bhajans, and then classical music. So the only jarring part is the Assi River emptying its water into Ganga. And as Professor Singh said, it is upstream, so it pollutes all the ghats in Varanasi. So that has to be taken care of. Some people have presented there are 3 types of advanced treatment process: advanced oxidation process, I would not go in, reduction, and then, one wants buy one, get one free. So if you could have a process which would have both oxidation and reduction, they would be much more efficient. So the process that I am trying to, this thing is to have ionization radiation, which will produce both oxidation and reduction radicals. The way, so what I have in mind, I mean, you can have radioactive sources, but because they can contaminate, they can be stolen, so, and they need to be replenished, so, or they have to be produced, so they are expensive. In that, instead of that, I'm proposing that you irradiate the water with 1 to 2 MeV electron beam, high intensity. So the ionization radiation, it causes excitation, which is this water molecule. It then produces H star and OH star, and the ionization where it knocks off an electron. So you have OH and aqueous electrons. So hydrated electrons, which we are calling aqua, is a reducing agent. Hydrogen atom, as everyone knows from our basic 12th class chemistry, is reducing agent. Hydroxyl radical is an oxidizing agent, and they join together to produce H2O2, which is again an oxidizing agent. So you have both oxidizing and reducing agents working at the same time to reduce the biodegradable waste. So in any process, this is the most number of radicals present. You can either have a reducing agent or an oxidizing agent, but could never have both. And nature helps us because the dielectric constant of water is very high. So it prevents the recombination of these ions. So why an electron beam? I will not go into the detail. It is eco-friendly technique, no secondary waste generation, no use of catalysts and heating as bioremediation or other processes require. It can be, is compact what we are producing, reliable, energy efficient, and easy to control. It removes need for chemicals such as chlorine and ozone, which produce carcinogenic compounds as byproducts. It removes organic impurities with radiation chemical reactions, color by destruction of double bonds in azo compound. It removes odor. I have collected some water from Assi very recently, and it was stinking. So by opening rings of aromatic compounds, and more than that, it removes 100% disinfection of microorganisms. As far as my understanding, I'm a new entrant. I'm a trained experimental particle physicist by profession. There is no process which is capable of reducing killing the E. coli bacteria, which is present in Ganga in a huge number, and only you have either UV, which only works for a very short time. At IIT Bombay, in our swimming pool, we tried ozonization. It did not work. So we finally had to resort to chlorination, and chlorination, we all know, is carcinogenic. It produces hypochlorite, and which causes cancer. These are destruction of endocrine disruptors, CEC, which I mentioned, removal of heavy metals by redox conversion. Arsenic is one which is present in the whole of Indo-Gangetic plain, and that is why you see a very significant rise in cancer cases in the whole of Indo-Gangetic plain, and they are on the rise. So we need to worry about it as soon as possible. I will not go into these tables. These are some of the pollutants that I have mentioned, and if we have a roughly, this is some unit of radiation that if we give about 2 to 3 kilogray of dose, there is 100% removal of coliform bacteria. These are all CECs, contaminants of emerging concern, which are present, but we are not yet bothered, and the removal rate is 100 to 90% can be seen from here. And this is not all. This is a lot of work has gone into it in Korea, and they found that if you introduce a electron accelerator in the regular process where you had chemical processes, it works much better, or biological process. So the results, without going much into detail, believe me, the references can be provided. Best results are obtained by electron beam treatment after biological treatment combined with coagulation and filtration. We could use the Professor Hamas from Israel was talking about how we are not able to reuse. The only way is to reuse or recycle our water. So it increases from 20 to 30% recycling, it increases to 70 to 80%. This would result a lot of water saving, and it removes the sludge that or the solid waste total organic compound by 80%. And this is the construction cost and the additional cost, and we don't require 1,000 crores for treatment. The existing facilities, if one adds an addition of electron beam, the best part is the economics is that within 5 years, the waters with not only do you meet the NGT norms, but because of recycling and less use of chemicals, the cost is returned in 5 years. This is the cost comparison for various activated carbon. Biochar is one option that we could use, which was a talk presented by Professor RHAR from McGill, I think. So combined with these two, and you can see that the electron beam has much better BOD, COD, and color and reuse percentage as compared to evaporation is one process, but it is very, very expensive. So how does conventional, just to give you a brief idea, you have this raw sewage, screens, commuter, then you have, and then this is the regular aeration tank was presented, how you aerate and do this. So this is a normal STP. It requires a lot of space. And then if you have coliform, then you need a tertiary or advanced treatment plant, which involves chlorination, ozone. My experience with the swimming pool, a small swimming pool at IIT Bombay, didn't work. We had to resort to chlorination to keep our pool. UV disinfection, again, is very expensive and very bulky. What we are proposing is an accelerator of this kind. This has been designed already at IIT Bombay on the computer. And you replace all this. This is just 3 meters in length. And what Professor RHAR was presenting, another 1 meter you add for biochar, and then you pass the water. Even the sludge you can use for, there is no sludge now left. This sludge can be used as a fertilizer, and it removes TOC. Everything is the tertiary treatment is done by EBT. You filter it out. You have a recycled water, which is as good even for drinking. So STP will become much more compact. You can fit it in the space that is available at Assi just before it meets the Ganga ji at Hassi Ghat. These are the various parts that we have designed. I will not go into it. This is a talk in itself, but the whole length is just 3 meters. So in a space of about 8 meter cube, we can accommodate the whole plant, which would be as good for this. We did some experiments because normally when you go, people ask, has this been done? We did this experiment with a medical linac, which was available in Samir, which is housed in our campus at IIT Bombay. These are some radiation calculations that was done by one of the students, and to effectively irradiate the sample, because this is a pencil beam, because it's a medical linac or electron beam, so we had to optimize our geometry, but our proposed system will be much larger in power. It is about 40 kilowatt and a larger beam scan area, so we should get better results. Even with this, we took the burst effluents that are possible, which are from pharmaceuticals, and there is a percentage reduction was as high as 66%. And you can see decoloration also, and some waste was left behind, which we have not missed. So we are not reinventing the wheel, but there is something new. These are various systems available or operational in various parts of the world. What is new in our system is that we use a superconducting machine, which is very efficient. The wall to the beam power is very high, 80% or so. So less power cost, less operational cost, and the operational cost comes to, I was hearing the talks in the morning, we will meet the requirement or will as competitive as any other system presented today or yesterday. So what has been done about this? This work is a part of a project which has been submitted by Government of India on our behalf to Government of Japan under the Science and Technology Research Partnership for Sustainable Development. It's called the SATRAP scheme. It took me 2 Skype meetings to convince the Japanese scientists that this project is doable, our country wants it, and it could be a game changer, not only for India, but for the world because of what I said, CECs, which are present even in Switzerland and in France, where they are the cleanest water in the world. Under this scheme, the scientists in Japan have submitted a similar proposal to Japan Science and Technology. This would now be evaluated by JST, and if approved, it would be funded fully by Government of Japan. National Mission for Clean Ganga, Mr. Mishra, the DG was present yesterday, are part of this proposal and agreed to put the pilot plant at Assi Ghat. So this is very much the theme of this. New Delhi Inter-University Accelerator Center, New Delhi would then make many more machines. The technology would be given by the team working from IIT Bombay to them. The first accelerator would be built by Japan with our help in Japan. The accelerator would be able to treat around 2 million liters of water. We have to multiply these accelerators to treat about 60 mld of flow, which we will do. We don't need any gradient change or anything. We can tackle it by putting more accelerators, and this would be built. Inter-University Accelerator Center at Delhi is agreed to it. The project was evaluated by Niti Aayog and Department of Atomic Energy. They acknowledged that India does not have that technology and it will be very useful to have it. The advantages of the proposed system, compact, not only in Assi, but in National Mission for Clean Ganga have identified 15 different spots where this could be used. Even otherwise, the space available is at a premium, even if you want to put it at Bombay for Mithi River. Suppose one wants to fit this on Assi River, a system whose footprint is 4 meter into 4 meter would be much better suited than a bulky system. These accelerator cavities, which have Japan has built with much higher requirement for a world project, which they can give 34 million electron volts per meter and have been tested on a test bench round the clock for years. With references for a normal conducting, Korea and other places, I tried to show you they were better than what is available, economically better, environmentally green and sustainable. So this is the evaluation of Niti Aayog, Water Division, along with Department of Atomic Energy. And I just highlight this. Superconducting LINAC is a new technology not available by Bhabha Atomic Research Center, who are expert in this area. Indian LINAC are not superconducting, and Niti Aayog strongly suggests to support this collaboration. This is the evaluation by National Mission, the technical team for National Mission for Clean Ganga. And I just highlight what I have just said. However, considering the area of research and the likely benefits accruing out of it for cleaning of Ganga, the Ministry of Jal Shakti and National Mission for Clean Ganga find a lot of value in this project, and Honorable Minister of Jal Shakti has also taken a presentation in this regard. This line is very important, since successful implementation of the project would go long way in cleaning Ganga in a far more efficient way than present. NMCG is very much interested in recommending favorably for this proposal. These are our collaborators. From IIT BHU, we have Professor Santosh Kumar, the head mechanical engineering department, as a co-investigator. I have myself, Dr. Abhishek Phatak, who is also from Banaras, MS Manisha Meena, Pankaj Kumar, Anjali Kavar, Pagya Nama from IIT Bombay. Director General NMCG, Mr. Mathuria, Senior Executive Director NMCG, Dheeraj Singhal. These are from Samir. These are my collaborators, and Professor Santosh Kumar and Professor Shishir Gaur are co-investigators from IIT BHU. Apart from other applications, there are other applications, medical sterilization. I will not like to go into detail and eat your time, but we have sludge treatment, flue gas treatment, cargo scanning, among others. So thank you very much for your patience and listening to me.
Thank you, Professor Raghav Verma, for very nice presentation and very interesting and enlightening us with a new technique, electron beam. So I hope you will get the project and we could see the demonstration at Assi Ghat. That could be a game changer, as you have said. So we look forward to see you very soon, and that too with collaboration with Namami Ganga and all other important agencies. So our next presenter is Dr. Veena Khanduri from India Water Partnership. Dr. Veena?
Yes, thank you, Nadeem ji. Thank you, Dr. Professor Singh, and thank you so much, Dr. Bhatnagar. It's a great pleasure that all the stakeholders of our Hindan partnership are today with us, and it's my great privilege to present today about the experience of Hindan, which can be helpful for Assi. Along with me, my colleague from Tree Grace Foundation, Bhawna, is with me, and we both are going to make a presentation. So Bhawna, can you just change? Hello, Bhawna. Can you just change the slide, Bhawna? Hello. Hello. Can you hear me, Bhawna? Bhawna, you are on mute. Yes.
Yeah, I was not able to. I think could you see on full screen?
No, I cannot see.
Okay, all right. Let me just share the entire screen and then I'll.
Yes.
Is it now visible?
Yeah, it's coming. It's not come up, but it's coming. Thank you. Thank you. Thank you, Bhawna. So just I wanted to brief you about India Water Partnership. It's a non-profit organization and we are working for supporting the IWRM. And we are basically engaging with lot of stakeholders, and our USP is to enable the stakeholder participation for stimulating public awareness and making the water challenges and understanding in a better way. Exchange of information between the individuals, government departments, and different stakeholders is one of the main part of this India Water Partnership. Our mission is you change, Bhavna. So our mission is to support the Water Secure India with the participation of all stakeholders. And our mission is to support action for sustainable and integrated development management of water resources at national level, regional level, river basin level, and local level. Bhavna, I can't see changing the slides.
It is getting stuck. Let me just stop sharing and again reshare. I'll not make it full screen.
Yeah, no need for full screen.
Okay. Just give me a moment. You can continue speaking, ma'am. I will.
Yes.
I will do that.
So along with us, Tree Grace Foundation, which is also a non-profit organization, is working with us as a stakeholder engagement. And they are primarily focusing on the rivers, which is the most neglected part of environment. And they have a model for continuous engagement of community in different age groups, taking them at different levels, creating awareness to ownership and to advocacy. So just talking about our engagement for Hindon and how it can be useful for the other stakeholders. It is great that today many stakeholders of Hindon are present, and we had done many exercises taking into the data into the consideration, and we have engaged basically the whole community by sensitizing through the different kind of story maps which we have created for making the awareness about the Hindon. Bhavna, can you change? So when we are talking about this engagement in the morning session, Professor Singh was just talking about the overall engagement, why it is important. And I feel that the stakeholder engagement is very, very important, because by engaging with different stakeholders, we can know what each one wanted, and there is a lot of synergy and lot of exchange of information. And because of this, we have been engaging with different kind of stakeholders which have the common interest and common causes. Next. So taking the example, one of the example which we are just sharing, it is the example of community sensitization. And first of all, to tell them about their own rivers. When we are talking about the Ganga, which is a very important river for the river rejuvenation. So we are emphasizing on the small tributaries, and we are talking about the village level river and how each village can take part in contribution. So by creating these very interesting story maps about the natural physiology of river, that particular river which is falling in their own village, on their watershed, and how this human interventions have impacted on the river physiology. So these are the very interesting story maps which we have created. We have given a lot of demonstration in the schools in English and Hindi, as well as we have given demonstration about these community sensitization tool to Ganga prairies and Ganga Doots. Now coming to the part which we are going to emphasize here, the dashboard. I wanted to invite my colleague Bhavna, who's working on the dashboard, and she will take and she will explain how and why we are working on this dashboard and how it can be helpful for replicating for the Assi. So
thank you so much, Dr. Veena, for handing it over to me. And this is such an important platform. We wanted to make use of it by sharing different technology, intervention that can be done. As in the beginning, it was mentioned that by the organizer that the entire problem of the river restoration is not only technological, as in not only can be solved by the treatment of the water, but it also needs a social intervention, and that's where we are focusing on. We are trying to use interesting technologies that are available to understand how we can make behavioral change possible. So one of the things that ma'am showed was a story map. The second thing that we have tried to make a pilot of is a dashboard that actually aimed at offering a one-stop solution for all data sets in the basin. So when somebody is curious that why a river is not getting restored, they should be able to see in one place that what are the important data sets and where exactly the challenges lie, what needs to be done. So without going any I would not take much of your time and start the giving you a look of the dashboard, how it looks like. So this is the dashboard which we are making it a public dashboard. anybody can log in, and as you can see, the first window is for signing up. Anybody can register. There are 3 different user frames that we have formed. In the advanced users, they can also update the data sets, because we realize that any data set is not, any dashboard will not work in long term if the data is not getting updated regularly. So this is the first look of the dashboard that we have created. And we are very happy that we could get this platform to show you this dashboard. And if we would be very happy if you could give us some feedback on how this can be improved.
Bhawna, can you share the full screen? Because in the chat box, someone has mentioned that they cannot see. So can you do that?
So this is a whole window that is being currently shared. And I don't know, is it not looking, can't you see the dashboard currently?
It's
You
not
can go to
coming.
presentation mode. You can go to the presentation mode at the bottom. There is a presentation mode in PPT.
No, this is not a PPT, sir. This is a website that I have opened currently.
But it's not reflecting in my screen.
So you are not able to see the dashboard currently?
No.
No.
Okay.
No.
Let me just again stop sharing and.
Bhawna, Mr. Manu has also raised some.
Yeah, sir. You can always speak. I mean. Yes, sir. Manu, sir, you have any question?
No, please carry on. I'm just putting something in the chat box for Professor Raghav Verma.
Okay. I hope this is visible now. Is it visible?
Yes, Bhawna, now it's visible. Now you can see. Yeah.
Thank you so much. So this is the first look of the dashboard, where you can see on one window you have the GIS platform, where we have added some of the GIS layers. You can see there are district, which is already seen here. We also have the drainages that we have extracted from digital elevation model, the STP that are available in Hindon Basin, the Hindon watershed that covers the 7 districts of Uttar Pradesh, the industries, and as you can see, all these red dots are basically the textile industries, which are in majority in Hindon Basin and mostly concentrated in Ghaziabad, Noida, and also in Saharanpur. If you look at the forest cover, I'm not sure if the color match, I mean, the color might be actually interfering, but in Hindon Basin, this is one of the major issues, that only in the upstream, only a very small portion is densely forested. Otherwise, rest of the area is dominated by agriculture. And this land use land cover actually shows you the exact thing. Almost the entire Hindon Basin is very, very dominated by agriculture, and this also shows the challenge that the river is currently facing. Now we have divided the entire dashboard into 2 parts. So one is the category, where we have some general information, and the second category is pollution, where we have pollution specific data sets. And in the district that you can see, there is another classification that we have done. One is where the entire Hindon Basin data sets is shown. So currently what you're seeing is for the entire Hindon Basin. But if somebody wants to go for each district, they can also go in each district and see what are the district specific issues and challenges that is being faced in the river basin. So this gives some general information about the population and how it is estimated to grow. The basin area divided into districts, the wetlands, the reserved forest, the rainfall, soil related properties, the forest cover, and as I was mentioning, almost 95% of the area is non-forested. So very small area is forested. So this is one of the major issues. Soil texture is also given. The groundwater level over the year, how it has changed, and we can very well see here that how groundwater levels are dropping with every passing year. In the land use, land cover, we see 76% of the area is agriculture. And if you look at the type of agriculture and the crops that are grown, you will see that 33% of the total agriculture area is being cropped by wheat and sugarcane and other fodder crops plus rice. So these are the four types of major crops that are being grown in the basin. And these are all very water intensive crops if you actually have a look at it. And please remember, in the beginning, we showed how the groundwater levels are dropping. And this is the gross irrigated area. And we can very well see that majority of the agriculture is depending on the tube wells and wells. So basically, they are tapping into the groundwater to irrigate their agricultural fields. And so there are three major things then that can connect. If anybody sees this dashboard, water levels are dropping. We are still continuing to grow water intensive crops, and we are still continuing to tap into groundwater. So these are all connected, and if anybody sees this dashboard, they can quickly connect to the challenge and issue. Here we have a look at the industries. The textile industry, as I mentioned in the map also, is the major industry in this basin in terms of number actually. Now let's go to the pollution part of it and how it is being shown. So we look at the sewage status, and if we look at the actual data that is being given by the action report of UPPCB very recently published, they say that the installed capacity is already catering to the sewage generation. So this is one of the things that ideally all the sewage should be treated. And but when we look at the drain discharge status here, we see that the total sewage discharge in the river is 585 MLD, but the majority of this is untreated. So here basically the two things don't actually match. Even though the treatment capacity is there, still a lot of sewage is going untreated. It may be because the households may still not be connected with the sewer lines, and a lot of the sewage treatment capacity is untapped. It is not being utilized properly. When you look at the total number of drains, we see majority of them are mixed. So domestic and industrial waste effluents are getting mixed, and they are flowing into the river.
Dr. Bhawna, can you please speed up?
Yes, sir. So basically, these are some of the things that we have tapped. We can also see the non-complying industries that are there, the waste, the kind of waste that is being generated, and the surface water quality. And one can also download a report from here that gives all these information plus some more into a PDF kind of format. So it may not be currently visible to you because I'm sharing a window, but that can be separately shared. The idea behind showing this dashboard is that we wanted first is to get feedback from all the eminent speakers here that what can be done to improvise, and also the research scholars, that what can be done to improvise, because the idea of this dashboard is that it should act as a one-stop solution for all the stakeholders. Because generally what happens is each stakeholder is only worried about what is it that they can do, and they don't want to see where in other areas there, because of them the issue is being enhanced or complicated. For example, the groundwater department may only want to see the groundwater levels are getting dropped, but they are not concerned about that in the agriculture department maybe they can do certain things like telling farmers to grow a less water intensive crops. So basically until and unless all the stakeholders come together and have a dialogue with each other, this kind of a very complicated rejuvenation of any river is not at all possible. So we want to make it into a decision support system. As I mentioned, this is our very first attempt, and this is a pilot dashboard. But we believe that this kind of a dashboard should be available for any and every river that is that for which we are trying to restore. Coming to the way forward, we believe that all the awareness materials that people are making now should take into account all the innovative technologies like the Google Story Map or the ArcGIS Story Maps that are very effective tools in giving away the information and igniting the young minds. Secondly, we feel that all the stakeholders should come together for a joint fact finding and a decision making. And for that, a centralized dashboard is extremely necessary for restoring a river health. The third thing for us is that one should continuously update the data sets and there should be a continuous stakeholder engagement. So all the departments should come together and see where exactly the challenges are and should work together to make this a possibility. And lastly, we feel that the kind of platform that RHAR has given, the kind of conference that is happening now, where researchers, administrators, NGOs are coming together and having a dialogue about restoring a river should be more frequent, and where people should come together and talk of how we can restore a river health. Over to you, Dr. Veena, and if you want to add some more points here. Lastly, before I end, I want to share a feedback form in the chat box. So anybody who has time, please have a look at the dashboard. I will also share the link to the dashboard. And please give us feedback on how to improvise it. Over to you, Dr. Veena.
Thank you, Bhawna. You have rightly pointed out that we have to first talk about the behavioral change, and second thing, through our this tool, we are focusing on the behavioral change, as well as we have mentioned that this is a pilot dashboard, and Dr. Nadeem, Dr. Manu Bhatnagar, and other esteemed stakeholders are present here, and we need a kind of decision support system which can help all these stakeholders vis-a-vis a common person also. So while we were working on this, we have come across with the National Mission for Clean Ganga, and we have interacted with the Ganga Doot and Ganga Praharies for these story maps, and also for the decision making this DSS support system. And we have received very good examples and stories to cover in the dashboard, which we will do later on. But I extremely feel obliged, because this is a kind of platform which is very much required, because either the practitioners are working or the academicians are working, but they are not working together. And this is the time when the action research and the academic research has to go parallelly. And through this platform, I think we can take up certain pilot activities which can be helpful for not only for the community, but as overall for the academician and the decision makers. So through this platform, we really required the kind of feedback which Bhawna have presented, and this is from our side. Thank you so much.
Thank you for giving the opportunity.
Thank you, Dr. Veena, Dr. Bhawna, for very elaborative presentation, and that too focused on the on River Hindon. So I hope this dashboard will be really useful in regenerating the rivers, especially Hindon, and we can have similar models for other rivers as well. Yes, Dr. Bhawna, you have shared the link for this poll, but I think we are running short of time, so we can have this poll later on the last part of this session. So moving on, I request Dr. Kaple from NIRI to give presentation on in situ Nala treatment. Dr. Kaple.
Yes, thank you, Dr. Nadeem. Happy to meet you online. You are already working with NIRI, but we have never met. So
Pleasure.
it's good to meet you here. And thank you to the organizers for giving me an opportunity to join up with all of you. Just give me a second to share my screen.
Yes, just a second. Those who have interest to give a feedback, you can just go ahead as Dr. Bhavna has already shared a link. Dr. Kapli can continue.
Yeah, one second. I'm just opening my presentation, then I'll share the screen. Something not right. I just don't seem to get my presentation on. It's not appearing. Is there? Share.
You can share the full screen and then go to the presentation. First, share the full screen.
First, share the full screen. Yeah, okay. You know, yesterday.
And then just click on the presentation. Go to the presentation and make it in the presentation mode. So then it will come.
Yeah. So when I do that, I'm just getting the screen with all your faces. So let me try window. Still doesn't come.
You are not sharing your screen yet. There
you
is
know,
an
I haven't. I have not yet clicked share because it is still not coming up.
No, so you say present now.
Yeah, I'm just going to that.
Now it is coming. Now go to the page which contains the presentation, the screen which contains the presentation. So if you click at the bottom on the PowerPoint, it will come.
Oh, okay. Can you see?
Not yet. You have not gone to the PowerPoint.
It's open actually. PowerPoint.
Yeah, but you have to click on that. Then you will also only see the PowerPoint on your screen.
Oh dear. No, there is something really going wrong.
At the bottom, you would have this, I don't know what system you are using, but PowerPoint would be mentioned somewhere.
Yeah, it's there, but it's just not.
Yeah, just click on that. Just click on that. You will also see only the presentation.
Yeah, it's not coming, but I'm clicking on the PowerPoint, but I'm able to just see, only I'm able to see it. I don't think you can see it.
Did you do entire screen
right? Even now it's not coming. Yeah, just a second. I'll make my PowerPoint a full screen. Will that help?
Yeah, first.
I'll just make the PowerPoint a full screen and see whether it works that way. Oh dear.
No problem. Just go now again and say present. Go to this meet and say present.
Yeah, I think I lost you.
I think no issue, Dr. Kaple. If you don't mind, can you share your presentation with Ms. Ria?
Yeah, I think I'll do that.
Yes, you please send an email, better in the PDF format, so that Ria can view.
Right.
Yeah, it will take half a minute.
Yeah, please. So can I get to your email ID?
You can also send me I can run your presentation also.
Yes, yes.
Tagore ji is there. Yeah? Fine.
Yeah.
I'm sending
There are many volunteers.
Yeah. Once, just give me a minute.
Just send me WhatsApp only, no? So I can.
No, it's not on.
Email you can also.
Yeah. सीताराम टैगोर पे है कि सीताराम सर आपका टेस्ट बताइए ना
ES गंगा
ES गंगा वाला
yes ES गंगा @smcg-up.org
ES गंगा @smcg-up.org no smcg
-up.org या either srtganga@gmail.com पे भेज सकते हैं आप. You can.
It's just not coming up. That's right.
SRT Ganga SRT Ganga @gmail.com.
Okay, I'm just sending it. Sorry about that. Maybe somebody else wants to go ahead by the time I mail it to Dr. Tagore.
Yep.
I think it will take half a minute or else I can continue.
Yeah, so maybe I'll present next. Somebody else can continue.
It's me. Is this visible?
Yes, sir.
So, I think we have already discussed 2-3 cases by Professor Shankar and Professor Verma about the different models and case studies, stories. So, in continuation to that, I shall be presenting another successful case story, what that can be. That can also be considered for rejuvenating or for restoration of dirty drains or small rivers. So this is I will skip these initial slides because Professor Singh has already said that no concept, no introduction, just come to the solution. So I hope everybody is aware. And we know the state of water bodies in India, especially River Ganges, River Yamuna, Hindan, and all of its tributaries, including some of the rivers in South India. So,
आ गया क्या?
नहीं अभी नहीं मिला मैंने आपको WhatsApp किया हुआ email ID ऑलरेडी.
Please don't speak when the speaker is speaking. You can chat.
WhatsApp पे भेज देंगे तो कोई इशू नहीं.
May I continue or you want to?
No, please continue.
So, Dr. Veena Khanduri has been associated long time with River Hindan, and these are some of the pictures that we got, like when I was working with the WRG 2030, like for River Hindan restoration. So it is a sorrow state of the water bodies, especially rivers in northern India, and because all of these drains, nalas are outflowing into the rivers. Untreated wastewater is finding its way into the rivers, making it dirty, contaminated. And we have already tried many options like Namami Gange. The efforts of Namami Gange are greatly acknowledged, but still we don't have any foolproof solution, and we don't see any visibility in the quality of our rivers and small tributaries. Now, I shall be presenting this as a case study 1 that has been the basis of development of a new method, or you can say which has been derived based on the R&D that we undertook in collaboration with European partners under the FP7 framework program, which was supported by Government of India through Department of Science and Technology. So it was a coordinated call where we had participated, Dr. Veena and Professor Singh, and maybe Dr. Manu Bhatnagar might be aware of this project, SWINGS, Safeguarding Water Resources in India with Green and Sustainable Technologies. So it was a consortium project. We had like about 20 partners, 10 from Europe and 10 from India. So, and it was a very diversified composition. We had academic institutions, research centers, leading research centers from Europe and India. AMU took the lead from Indian side, whereas AMN Research Center in Vigo from Spain took the lead from European side. So the overall objective of this project SWINGS was to develop or deploy optimized sustainable solutions for wastewater management, especially domestic wastewater, in order to make full use of water resources for different purposes like for irrigation, cleaning, public, private demands, aquaculture farming, and with the basically with the focused on very less energy demand for rural areas, towns, communities, and arid regions in India and region. So this is the same thing like I have already explained there about the aim and objective. Now as far as the location of the piloting that we did under SWINGS, it was there were 3 sites, one at Aligarh Muslim University, Aligarh, then Kalyani University in Kalyani, West Bengal, and the 3rd site was in Amarkantak in the Gandhi National Tribal University. So in AMU site, we had 3 pilots, whereas in Amarkantak we had 1 pilot plant, and in Kalyani we had 2 pilot plants. So the domain of the technology that we implemented throughout the project SWINGS was the development or deployment of very innovative or novel concept of constructed wetlands. So it is basically again a phytoremediation technique. We have already talked on phytorade and other similar nature-based solutions yesterday and today itself. So it is we are not reinventing the wheel. It is the proven technology, and India. And if you just see the history of India, so this technology or this concept has already been experimented and implemented maybe 1,000 years before. But what the Europeans and other developed countries have done in this particular technology, they have given a very scientific shape and engineered way of doing things. That is their basically expertise and their inputs. But as far as the implementation of this technology is concerned, it is already there in palaces, in many like forts in Rajasthan and in Gujarat. So this is the aerial view of the AMU pilot plant. We have 3 pilot plants within this site. Now, this is the first is based on the anaerobic followed by vertical and horizontal flow constructed wetlands. Then the second one is based on the French type system, which is again a modified form of the wetland system. And the third pilot plant was basically disinfection using solar energy of the treated effluent from both these pilot plants. I'll skip this slide. This was basically the questions that when we started this project in 2013. So, and we also did thorough interaction and visits to the Europe and other countries where this technology has been successfully implemented. So this is this picture showing one of the pilot sites from our partners based in Germany, Leipzig, Helmholtz Center for Environmental Research. So this is the pilot plant which is located in one of the villages on the outskirts of the city, Leipzig. And you can see the quality of the raw sewage in my right hand, and it is the treated effluent which is coming out. And similarly, we have this another vertical flow constructed wetlands in southern Spain that I got chance to visit. Now, this is the treatment scheme of AMU pilot plant. What we are doing, the entire sewage of AMU campus comes at the existing STP of owned and operated by AMU, which is based on the trickling filter technology. So we have tapped a stream of raw sewage from that STP, and it is brought into this tank. This is the collection tank, just a holding tank. It is not part of the treatment process. So from here, it is lifted to a first step of the treatment, that is anaerobic digester, or you can say which is based on the principles of anaerobic process, but it is a USB technology which has been widely implemented in India. Then after this first stage of treatment, the wastewater goes into the next stage, that is vertical flow constructed wetlands, and followed by horizontal flow constructed wetlands. And finally, we do disinfection through solar-driven methods. So one is anodic oxidation process, and just to make comparison, because this was an R&D project, so just to make a comparison, we also installed UV radiation method. So this whole scheme is self-sustainable, and it doesn't require any energy. So the only energy which is required is just the first pumping, which is, I think, almost true in all the STPs wherever you treat your sewage. Now, these are the actual pictures of the treatment scheme. You can see the USB reactor, and then these are the vertical wetlands, and here you can see the pipes with some top like in the plastic material. These are basically the aeration ducts, the natural aeration ducts, which is going beneath into the bed, so that the bed is never like a deficit of the oxygen. And then this is the horizontal bed. So if you just see the results of this pilot plant, which is under operation for last 5 years. So this is the summary. So this BOD is about 170. This is the normal BOD range. And finally, what we are getting, BOD at the outlet is nil, and COD less than 5 milligrams per liter, TSS nil, total nitrogen nil, total phosphorus. So we have already published more than 17 papers on this project or on the findings of the project swings, including from Amarkantak and Kalyani. So another configuration of the wetland system, which is very common in Europe, especially in Germany and France, it is the French type of wetland system. In this type of wetland system, the beauty is that it doesn't require any pre-treatment like in the earlier configuration, where you need some primary treatment like anaerobic digestion or primary sedimentation or some sort of treatment is given. But in the French type system, no primary treatment is required. So this basically requires less footprint as compared to the conventional wetlands. So this is the first stage of the French type of system, and this is the conventional horizontal flow system, so that water, the treated water is free from all the pollutants, and it is taken to the aquaculture pond where we are doing fish rearing. And this is the quality of the effluent which is coming out of the horizontal flow wetlands. So this picture was taken by one of our partners recently, Dr. Carlos from RS University, Denmark. This is the actual view of the vertical flow wetlands at AMU. You can see the vegetation is basically phlegmatous Phragmitis calca and Phragmitis australis. So harvesting is done after every 2-3 months because these are emergent plants, macrophytes, that can grow up to say 2-3 meters. So you have to basically harvest this vegetation after 2-3 months interval, and this harvested biomass can be used by farmers for their homes or for making their roof of their huts and other purposes. Now these are the pictures of the solar-driven disinfection method. You can see this is the anodic oxidation process, which machine that we got from one of our partners from Germany, Otterkorn. So what we are doing in this anodic oxidation, the chlorine which is present in the sewage, the salt, the NaCl, which is present in the sewage, is basically it is converted into a chlorine gas, and that chlorine gas helps in disinfecting the wastewater. So it is fully automation and SCADA-based system. So it produces chlorine as per the demand, as per the level of the coliforms in the sewage. These are the graphs which I will skip. Now with successful implementation of the project swings, so we are now replicating this technology throughout the country. So this has been adapted by the Ministry of Education and Namami Gange. So we have already installed plants at these locations like Kalaburgi, Kolar, Raigada, Ratlam, Morbi, and we have many other quarries. And in Lucknow, we have 3 plants. Nowadays, we are doing a big project in Pondicherry for Pondicherry University. So this is the animated view of the STP that we used to provide. Like you have this main collection sum, then followed by like this inlet chamber screens and biodigester, then vertical flow and horizontal flow, and finally the chlorine contact tank and the treated water. So this water at all of these places, the treated effluent is being used for gardening, horticulture, or fish rearing. Now, with this concept in mind, we thought to develop wetlands technology for on-site treatment, like in situ treatment of the rainwater. So we developed this concept, and this has been applied for patent. And we have already done 6 nalas in Bithur near Kanpur, and we are doing one big nala in Agra near Taj Mahal, that is East Gate drain. It is 2 MLD capacity drain, which is flowing just on the side of the Taj Mahal. So, and this picture, you can see this is Bithur, where we have already implemented this technology in six nalas in Bithur. Otherwise, it was outflowing into the river Ganga. So this is one of the nalas in Bithur. The situation before implementing wetlands. So this was the construction stage, and finally it is the wetland system that we installed. So this is the actual view of the wetland system. So you can see the quality, like this is the raw sewage, which is very diluted in most of the nalas in India, and this is the middle stage treatment, and this is the effluent which is coming out. So BOD is less than 10, COD is less than 30, and TSS is less than 20. And finally, we do this disinfection with the help of the chlorination. So that is the conventional process of doing disinfection in India. Now, with these 2 successful case stories, we participated in another call where NEERI is also, at Dr. Kaple mentioned that we are working with the NEERI. So this is the project she was basically mentioning about. We have IIT Kharagpur in our consortium, IIT Dhanbad, Namami Gange, National Institute of Urban Affairs, then 2-3 SMEs and 1 NGO. Similarly, we have partners from Europe, like 12 partners from Europe, RS University, Helmholtz, Moku University, 2-3 SMEs, then Helmholtz Center for Environmental Research, Germany. So NTTZ is basically the leading coordinating agency, and AMU happens to be the leading coordinating agency from Indian side. So this is the project Pavitra. We are basically experimenting or doing piloting at 14 locations in India. So this is much bigger than the project Swings, and it comes under Horizon 2020 framework program. And from Indian side, it is again supported by the DST. So this is the new project that we have started, and we already had a consortium meeting in Aligarh, and you can see one of the directors, Dr. Mathuria, visited Swings project when we had a meeting in Aligarh in 2019. So these are the locations of the pilots under Pavitra. We have 6 pilot plants at Aligarh nearby, then in Dhanbad, over 2 pilot plants in Dhanbad, 1 in Kharagpur, Vizag, Nagpur, 2, and then Pune, 2. So we are not only doing wastewater treatment, but we are also trying to do experiments, demonstration studies on fecal sludge management, then energy from waste, then short rotation forestry, and we are also trying to develop some new sensors based on the nano technology, so to monitor the sewage treatment plants, especially the anaerobic processes. So it is a very diversified kind of project that we are now implementing in India. Thank you very much. Thank you. So, if
now we have Riya Ranjan Srivastava.
Oh. Yes, sir. If Dr. Kaple is going to present.
Yeah, Dr. Tagore is going to run the slides. Thank you, Tagore-ji. So I'm going to talk about what NIRI has developed and we have implemented at Prayagraj near the Sangam point for the Ganga. And this was during the Kumbh Mela, and even Tagore-ji was also part of our team who was looking after this project. So basically, it is an in-situ drain treatment technology that can be applied to any drains that are leading into the Ganga or into any river. So next, please. Normally, when we say rejuvenation of a river, you have so many different procedures that you can do it. So constructed wetlands, we have heard just now from Dr. Nadeem. So many different variations of this constructed wetland systems are there. Even what Dr. Shankar presented in the morning is also one version, like a phytorid that also uses these wetland kind of a system. Dr. C.R. Babu from Delhi, he does this very extensively. The other methods you could use, reconstructing the catchment area, desilting, and there are many other options. And one of those options is targeting treatment of the drains that are leading into the rivers. That is basically where the pollution comes in. Next. So NIRI has developed this technology called Renew. You can see on the left hand side, we have the Kacha Nala, and we have converted that into this panel that you can see here. Next, please. So it's not only about the aesthetics, but you can just see from the picture, the water quality also shows a lot of improvement. Next. So basically what our treatment does is it's a decentralized treatment option, as is quite evident. And all our treatment goes within the drain itself. We utilize all the components of an STP, like you have sedimentation, you have a primary treatment, you have aeration. So all these components we incorporate within a flowing drain. the flowing drain does not actually only contain the wastewater. Everywhere across India, the problem of solid wastes being dumped into is also there. That is an additional thing. So we convert these drains into a Paka drain, having different components or units within the flowing drain. So we don't basically take up any extra space outside of what the natural path of the drain is. Next. These are the locations at Prayagraj. Next, please. So these are the drains at Prayagraj that we took up. You can see the red arrows. They indicate where the drains were, which you saw in those Google images. And all of them, they join a main drain and they lead directly into the Sangam point. And the Sangam point, as you all know, is where basically the holy dip happens and the pilgrim bathing site is one of the most important bathing sites. So all these drains, they directly the treatment of these drains is extremely essential, because otherwise all the devotees are getting exposed to sewage that is coming directly from these drains. Next. So our treatment incorporates screens that take care of the floating garbage. We have a sedimentation tank which is incorporated into the drain. We use biomats, and we have aeration chambers. I'll show you some pictures of those. And in the end are the flow rafts, which are these floating rafters on which we put these wetland plants for the take up of the excess nutrients. Next. So I'm the biologist of the group, and we have engineers. We have actually the team that actually tackled these projects contained of a biologist, that is me, a chemist. We have engineers also on the group, civil engineer and chemical engineer. So basically the topo survey was initially done to understand the lay of the path, and whether we need to change an elevation and things like that. Next. The length of the sedimentation tank is calculated based on so many parameters, basically on the load and the length available for treatment. Next. We use biomats. Next, please. So we use biomats in which we immobilize our bacterial consortia. And since this is all sewage, so we have bacteria that have proteolytic, lipolytic, and amylolytic activity, which is these are immobilized. We have tested it with different immobilizing agents before we incorporate them into the biomats. Next. So aeration is little difficult, because it's not like this is a decentralized treatment option, and so there's many times there is no scope of getting electricity. So we have incorporated solar panels that are placed across the drain, and they are connected to a compressor that and a battery, of course. So there is a constant aeration that is being supplied into the drain for the aerobic biodegradation process. Next. So these are some pictures. This was done by the Namami Ganga project at the time of the Kumbh Mela, when they had the state mission of Clean Ganga was looking after this for treating all the drains. So Niri was given 6 drains. So on the right, you can see the difference in the water color, as it comes out. That is the last gate before it joins into the river. These are also some more pictures, so you can see. In fact, I'm really very proud to share that the drain treatments were so appreciated. We even had the Honorable Minister Shri Nitin Gadkari ji, who put up pictures of these during the Kumbh Mela on his Twitter handle. The efficiency, yeah, you can go to the next. So We have monitored efficiency of all the different units of our treatment structure. We have a number of units, within different gates along the drain. The only problem that we face is the fecal coliform. So most of these places, the monitoring of the performance was given to a third party. It was done in this case by CSIR IITR, and we have seen very good results of reduction of BOD and TSS and everything. The system itself has a lot of advantages. Main is that it does not require any extra additional space, and it can treat it as the drain flows. Since we build restraining walls, so if you have sudden shock loads, the system can take care of it. Because like what happened during the time of the Kumbh was, the actual drain, the flow was 3 or 4 MLD, but during the Kumbh it went up to 10 and 12 MLD. So our system was still able to take in this kind of a shock load. It's very low on maintenance. It just does not require very skilled labor, mainly only desludging at the sedimentation tank and maintaining the plants. It also gives you a very good aesthetic appearance, because now you have converted that drain tree water which was flowing into a beautiful looking with plants and flowering. You use canna, you have very nice flowering plants. So there are a number of advantages. Next. It's also very cost effective. We did like a comparative statement. You compare it with a conventional STP, and you can see highlighted in red if you just hypothesize for all the wastewater that is being generated in class 1 and class 2 towns, the renew comes out to be very much cost effective than the normal STP. So we always propose decentralized treatment options in India. And it's not only just about creating the STP. You need to change the entire sewerage system, which is a different cost, which is not included in this calculation. Next. So this can be done, at any of the drains. If we look at the river Varuna, then there are about 17 drains, of which 11 are untapped. And so this kind of a system can easily be put up in all this. So you are already treating the water that is entering into the river before you make any other kind of, this would be an immediate arrangement that could drastically halt the pollution going into the river. Next. So it's not that it's without free from any constraints, but the main constraint is people's perception. So you can see from this figure that this is supposed to be a wastewater drain treatment, but that wall you can see on the first panel is the wall of an ashram. You can imagine that in Prayagraj how so many different ashrams, and when they have a festival or an event there, so all the patals are dumped into the drain. It is just a matter of creating responsibility. All this is solid waste and it should be actually dumped in a separate place. They could have just collected all the solid waste and put it on a different site, but it doesn't happen. So every other time we need to hire labor who dig this all out of the drains, so that the treatment, so obviously your treatment efficiency gets hampered. Then there is a problem of theft, because these are not these are in open grounds, these drains. And so you can see that most of the screens that we have put up, all the rods have been just taken. And so there are these kind of constraints, and the only way to deal with these constraints is to get the people involved. The awareness and the responsibility sharing of the citizens who live in and around your treatment process is one factor that is, I would say, mostly neglected. All of us, the scientists and CPCB, the Pollution Control Board, and everybody, we are just so focused on the technology and the implementation methodology that we forget the main thing about, creating awareness. That's not yet actually being addressed. And without people's participation, whatever treatment system you are going to set up is going to land up like this. Next. Next, please. So what we did actually at Prayagraj was, when the principal secretary was Shri M.K. Singh, and you can see also the chairman of the UP Jal Nigam in this picture. We actually created an awareness camp for solid waste management, and the entire executive officers from the UP Jal Nigam had attended, along with the governing bodies, the sarpanch and their team also. So I'm not really very sure now how much they are still participating in this, but I feel that these kind of awareness camps are extremely important even before we start the projects, so that the people living in and around the places that we are trying to treat, they are able to join in and take responsibility of at least keeping your treatment intact. Next. So this I had just prepared, keeping only Niri in mind, but for the Jal Nigam. But of course, now the team expands with IIT BHU taking the lead, and all of us together, I think we should be able to achieve something. We have heard from yesterday so many different wonderful suggestions actually. So we incorporate the lacuna that is there in each of ours and make one holistic approach that can be actually implemented very quickly. Thank you. Thank you, Tagore-ji.
Okay, we are really running short of time now. So maybe Ria, you can.
Ria, unmute your mic, please, Ria.
Yeah. Yes, sir. Can you see my presentation?
Yes.
Yes. And is it changing? Yeah. Thank you so much,
Yes.
Professor Khalil. A very good afternoon to all of you. I'm Ria Ranjan Srivastava, Research Scholar in the Department of Civil Engineering, IIT BHU, working under the supervision of Professor Prabhat Kumar Singh, with the very organization of this esteemed conference. It is a great opportunity for me to present in front of such an enlightened audience. Here I'm going to throw some light on Assi River restoration using reclaimed water from the nearby STPs. So firstly, River Assi is said to have been a major river for Varanasi city, so much so that city even derived its name from the two rivers Varuna and Assi. However, the once 120-kilometer long river Assi has reduced into a mere nala of 3.5-kilometer length due to various anthropogenic interferences such as urbanization, industrialization, and land encroachment. The current origin of river Assi, as can be shown in the map, is said to be from a port called Kanchan Kulpan, whose source is wastewater generated from the nearby area. If proper interventions are not made, this river with such historical relevance will become extinct. This river, which does not have a perennial source, will eventually dry out if not augmented. The confluence of River Assi and River Ganga is shown in this image. It can be seen that immediate quality improvement by dilution of wastewater stream from Assi does not take place, and hence wastewater flows along the ghat for a while, making the water extremely unhygienic for humans as well as affects aquatic life too. Till now, most of the STPs installations in India were focused at safe discharge into river system. However, we need to become the buyers of reclaimed water and start utilizing wastewater as a new potential source of water. We need proper visualization and defined targets for achieving an efficient water sufficient system by closing the human water cycle loop. In this work, we suggest appropriate technologies for wastewater treatment plants and different routes through which River Assi could be augmented from nearby STPs, hence providing a continuous, cleaner support to this river system. The target quality of the effluent produced from these STPs are taken as that for discharge into surface waters used as a source of drinking water as defined in CPHEO 2013 manual, and outdoor bathing as defined under Class B category designated best uses. Two STPs falling in Assi River catchment, which are ASP based DLW STP and a new coming up SBR based Ramna STP, are considered in this study for contributing to Assi River revival. The locations and elevations of the STPs as well as the ponds are shown in this map. So Route 1. Route 1 asks for redirection of water from Ramna STP to Kardameshwar Pond, which is designated as Pond 3 in this map. Here, Ramna STP is proposed to augment the ponds at the very mouth of the river Assi, thus providing a continuous flow support to the river. The length of the route is 6.67 km till the Kardameshwar Pond, which can be connected to a 2 kilometer distant Kanchangun Pond, which is at the mouth of river Assi, after which the mixed effluents can take the natural flow of river and undergo natural processes such as sedimentation, dilution, filtration, biological degradation, and contribute to better quality before the confluence of both the rivers. For SBR-based Ramna STP, supplementation with Verma process, which is a post-denitrification process, is suggested. It will lead to reduction in the fertilizing nutrients present in the river. Although effluent from Ramna STP itself will not be sufficient for overall improvement of the Assi River. In this study, the least weighted cost approach, which is utilized for ranking of technologies, where based on resource availability in the local conditions, weighted costs are obtained and technologies are suggested. We have basically reviewed technologies analyzed under various river action plans and published literature and ranked them on the basis of least weighted cost on the basis of these resources available in the local area. Route 2 is Ramna STP to Assi River via BHU campus. This route suggests direction of effluent as can be shown in this map from Ramna STP to a proposed STP in BHU campus from there where the effluents from both the STPs can flow under gravity towards discharge point in Assi River near Girls Polytechnic College. The total length of this route is 6.54 km. The technology suggestions for the proposed STP in BHU campus are as shown. These are suggested considering limitations in land and energy resource availability to obtain quality suitable for defined target reuse purposes. These technologies are SBT, Bio4F, SBR, and A2O. SBT, as was emphasized by Professor Shankar earlier in his presentation, The STP in BHU campus will not only help in restoration of Assi River but also contribute to environment by municipal wastewater management in the BHU campus. Route 3 is directing water from DLW STP to Kanchanpur Pond. This route suggests redirection of effluents from DLW STP, which is an ASP-based STP, to Kanchanpur Pond, designated as Pond 4, where the current form of Assi River starts. It's a route of length 1.82 km with a RL difference of 1 meter. And the fourth route is DLW to discharge point near Pond 6, which is near the Girls Polytechnic uh, College. This route suggests gravitational flow of effluents from DLW STP to discharge point near Pond 6 due to the elevation difference. The effluent from DLW STP, whereas needs quality improvement, and so technology upgradation or supplementation of this ASP-based STP is suggested. Following technological suggestions are made. Due to high costs, installation of new secondary treatment technologies along with ASP technologies is suggested in place of augmentation with advanced treatment processes such as ultrafiltration, microfiltration, and reverse osmosis. Since the source of river Assi in the current form is wastewater generated from the nearby area, mixing of very high quality effluent from one STP cannot serve the purpose of quality improvement completely. Hence, a combination of the suggested routes will perform a better work for achieving the target of Assi River restoration. Here, there are two routes being shown from DLW STP to Kanchanpur Pond, which is marked as Pond 4, and Ramna STP to Assi River via BHU campus. This route will provide continuous flow support at the mouth of River Assi near Kanchanpur Pond. The mixed effluent from here, while following the natural course of the river, will be further joined by effluents from Ramna STP and BHU STP. Addition of second source of treated effluent to the mixed effluent flowing in the river will further replenish the self-purification capacity of the river and by again boosting the kinetics of microbial degradation.
Ria, kindly
Yes.
wind
Yes,
up
sir.
quickly.
Yes, sir. So the last combination is from DLW STP to discharge point near Girls Polytechnic College and Ramna STP to Assi River via BHU campus. This effluent release is more or less at the same discharge point. I'd like to conclude the session that all these implementations need to be done keeping in mind the capacity of the river, the target quality, the influent wastewater characteristics, aquatic life in the river, and the economic and other restraints. And most of all, it should ascertain the safety for human use. In-channel treatment of the river near the end or along the course and of connected ponds is suggested that can very efficiently contribute to further improvement in the Assi River revival. Also, I feel a combination of ideas being presented here, such as biochar filtration, enzyme application, photoremediation, will provide with a proper implementation program can contribute immensely to our target of river Assi restoration. Whereas we do require a flow support for river Assi, otherwise the river Assi will dry out. Thank you. So I'll hand it over to Professor PK Singh if he has any suggestions to make.
No, thanks. Let's stop it for here. And we are running short of time. Professor Nadeem, what is our position?
Only one speaker is left. And in the second theme, we have 5 speakers, but I have doubt whether we could comply with the time. So I don't know. It's basically.
Actually, in fact, let me clear. Professor Keshri is there from IIT Delhi. He will be speaking, but these 5 names, this is a group of people, and
Okay.
I do not know how many of them are there. But then idea is that they are the experts in phytoremediation, bioremediation, this bioenzyme kind of processes. for river restoration. So the idea was that they will be discussing among themselves, and a kind of Professor UN RHAR is here. A kind of action recommendation will come from them, which will be suitable for the different stretches of river Assi, if at all. If this is the recommendation.
Okay. So let us give time. Let us give opportunity to Professor Kesri to listen to him.
Yeah. Please welcome. Thank you.
Suresh Babu is also there, but I don't know whether he is available or not. Dr. Suresh Babu.
I'm not seeing him joining.
Yes,
so
yes. Professor Kesri can continue.
Professor Kesri, yeah.
Professor Kesri.
Yeah, thank you, Professor Nadeem, and thank you, Professor P.K. Singh. I really am thankful for giving me the opportunity to speak here. So, distinguished delegates and all the peoples who are attending this today, this is my pleasure to share some of my thought on this important topic. So, I'm going to share the slide now. I hope this is visible to all of you.
Yes, it is very well visible.
Okay, thank you. So I'm going to speak basically on the re-aeration in degraded rivers. Primarily I have been hearing from the morning and also yesterday, you have observed that the re-aeration process is one of the things which basically rejuvenate the river. It gives the life to the river, or it gives the self-purification capacity of the river. So the question comes here, mostly whatever we read in the different technology or different techniques or whatever we have the basic engineering knowledge, they are primarily those are going to be applicable for a river which remain healthy, but especially the rivers which have already died up or which are in a very dying stage, that is what I'm labeling them as a degraded river. And that is what it is true for the Varuna and Assi here. So how you are going to really give a life to the river, it basically depends upon how you are devoting time on the re-aeration. Certainly there are different technologies are available for the different way of handling the river problem. But certainly these things are going to complement each other. It is not something it is going to substitute or replace a particular thing. So handling such a situation in degraded river, certainly you need a combination of the methods which can help and then revive the rivers. So I'll be speaking in this thing, in this, the context. And mainly, as you have seen, that the river health is deteriorating because of the wastewater which is generated in most of the city or in most of the places. And the wastewater generation is always, the increasing manifold. And that is the reason why the managing the wastewater is becoming a major challenge. And this challenge is for both. Either you talk about the industries and the domestic sewage water. So the handling the wastewater generation really is a top job, and that is the concern. And what we find that most of the time, a large portion of the wastewater, which is either untreated or partially treated, not up to the desired level, they find some way, some path to join rivers or the streams and contaminate it. Not only rivers, it basically they contaminates even the groundwater. So the level of the pollution, either talk about the river or groundwater, that vary in nature, complexity, or you talk about the dimension of the severity. So that is what the major concern we have. And what we see that not even a single city you can find it out where the fully treated water is there. And the water which joins to a river system is totally free from any kind of the contamination. So you'll find, first of all, the less infrastructure available for the treatment facility. Secondly, that even you have at some places, you'll be getting a situation, real life situation, where the partially treated or untreated wastewater, you'll find some pathway to join the rivers or the streams. And of course, that is going to also to groundwater, because you'll be having a dynamic situation in connectivity between the rivers and the groundwater through the stream aquifer interaction. So when we talk about the river health and the water quality, when we try to simulate, as you know, and you have already heard by many learned speakers, that in all the rivers or streams, the inherent capacity, whatever you have to assimilate the pollution load, that depends upon basically the reaeration capacity or how the self-purification is going to be done. So the primary the processes which is going to involve, in handling the problem, certainly the treatment is one thing that you are treating, and then only you are releasing water to the river. But you also need to know that what is the flow condition in the river, whether it is very low or high, or it is fluctuating very high. Because the reaeration processes are going to be governed by many processes. Like here, the physical processes which you see here is something the self-purification, the dilution or absorption are going to control. So these are something which will be responsible for the physical processes to give the reaeration capacity. The chemical processes, certainly you need the oxidation reduction process. We had also some lecture by the esteemed colleagues. The biological process, that is how the nutrient interaction is going to be with the nutrient or the algae production, or even the interaction between the sediment which is present in the river and with the pollutant or the contaminant. In general, the reaeration for modeling or for river water quality simulation, we follow different approaches, and most common approaches you might be knowing, that is the rational approach, which is primarily involving the hydraulic properties, mainly the depth of the flow, the flow velocity, and the empirical approaches, which are basically based on the statistical techniques, where you will fit a regression and you find out what could be the reaeration capacity or reaeration for a particular river or a particular stretch of the river. So what we see, that none of the approaches, whether you talk about the rational or the empirical, you'll find that they are going to show a good result, especially for that kind of river which receive high organic load from anthropogenic activities. And that is what happened in the Varuna and Assi. I'll just show you something here, a typical situation for the wastewater scenario. And in most of the city, depending upon whether you have class 1 or class 2 city, as you know, depending upon the population, the wastewater generation is something of this order. You can see it here, and the treated is something around 24% in many of the city, and in a smaller city you will still have very less the treatment capacity, that is 4% only. So most of the time you will be observing a high amount of the untreated or partially treated wastewater join the river system, and that becomes a challenging problem here. If you look at here, River Yamuna, since I'm sitting in Delhi, we have done a lot of work with reference to the River Yamuna. So I'm just showing you here that you see the Yamunotri, where the river originates, the River Yamuna, and see the stretch in Delhi, how it looks like. If you look at the figure here, the right-hand side, you can always say, without doing any kind of the scientific analysis, the river is in a bad shape. And that is what the question comes, whether the river is still living or dying. Although we recognize the river as ecological entity now, but think of that what kind of the situation we have. So if the river is already in a dying stage, how it is going to assimilate the impurities and how it is going to give the self-purification for its own. So that certainly that demands a greater concern or greater, the integrated effort for handling such kind of the problem. See the quality here. So if this is something showing the BOD level for a typical situation, and this 0 is indicating the Wazirabad barrage location. And if you go downstream of the Wazirabad in River Yamuna in Delhi stretch, at the downstream around up to 10 kilometers, you see a high BOD level, more or less around 40 milligram per liter. And the DO level, if you see after Wazirabad, it is almost 0. So is it a aerobic condition? Can you call this as an aerobic condition, or it has already gone into the anaerobic condition? So that is the question comes here. And if that is the situation, how you are going to define mathematically or scientifically that what could be the reaeration capacity, how it is going to digest any kind of the pollutant load in the river system. If it has converted into throughout the season, sometime it will be something like an aerobic, sometime anaerobic, and how you are going to handle this kind of the situation. If you talk about the river Varuna, and already we had a lot of the information on the river Assi, but if you see the river Varuna also, this also characterized with a different kind of the system, like the low flow you have very low flow during the non-monsoon time. The similar thing we see in River Yamuna here. The polluted stretch is around 202 kilometers from Bhadola to Varanasi, and when it is a confluence with the River Ganga at the Keshwar Ghat, and in between this, we observe that there are 14 drains which carry wastewater, and that join basically River Yamuna. But see the composition here. The most of the wastewater is primarily because of the domestic sewage water, and that is where when you are talking about the STP, certainly that needs a very adequate attention for this particular site. And the industry is having very less contribution if you talk about here. But if you look at the treatment capacity, we have merely 51% the treatment capacity. So that means the remaining 49%, where that is going? That is going to river, and that is where it becomes a problem for the contamination. And when it travels during the river course or through this drain, certainly a lot of water, some water percolates down also. So that means during the travel or during its course, it is going to contaminate you the groundwater also. If you see the confluence around the Varuna River, the drain with the Varuna River, we see the BOD in the range of those drains around 65 to 70 milligram per liter, where COD is around 512 to 588 milligram per liter. And if you talk about the water quality before the confluence of Varuna with the Ganga, and you can see here the 36.90 milligram per liter is BOD, and DO is very less, 2.23. So think of, we say that it should be 5 milligram per liter to support the aquatic life in the river system, but the DO is so low. So at this so low condition, how much it can assimilate? And that is the question comes. So you need some kind of the intervention, and that is what I put as a managerial, or I can say the technological intervention here of this kind. Like you need to have some intervention in the process, how the process is taking place. You need to have some technological intervention which can revive the rivers. And of course, we also need the operational management. So that means you need to have a complementary, the approach which must include all three. So that means something in the process intervention, something changes in the technology, and something changes how you are going to manage and how it is going to operate when you have already implemented. And there by combination of these three, you may be able to achieve the desirable result. Now I'm just going to focus here, and I'm going to tell you here what the processes or what the technology we must keep in mind. The first thing is that waste load allocation. How much waste load should be allowed to join the river? Certainly the situation as we see here, when the BOD is so high and DO is so low, we should theoretically, you can say there should not be any load. So there should not be any load of the pollutant to the river system to revive it. But certainly the practical difficulty of implementation will be difficult. So that's why you need to know what should be the allocation, that optimal allocation. The river can still remain the capacity of assimilating the impurities. Secondly, that you must have the intercepted drains, which basically they tap or interrupt the polluted wastewater higher from highest the stressed stretches, and then you treat them, take to the treatment plant, and then only it should be released after the treatment. So that is where and why it should be released, because after some treatment should be released to again have the flow augmentation. So the question comes here that you also need to have the augmentation of the flow, so that you have a good velocity, good discharge, good water depth, and so that it basically have good aeration capacity. So that is what naturally you can do. But we also need, in such a bad situation, some system of artificial re-aeration. So there should be something we can think of, like in the morning session we have been hearing that was the bubble tubing. That was one kind of the technology was suggested. So certainly we need to have, like we may have even some kind of the Gabian kind of the structures. We can have some kind of depending upon the topography, how you can have a cascading effect to give the artificial re-aeration in situ in the river system. So there should be some kind of the technology should be employed here to increase the DO level, and that is what we mean here. The another thing, now we need to have the constructed wetlands also. Recently, we have just the designed one engineering design we have carried out for a constructed wetland for the main drain in the Noida. That is the big drain. On that we have designed this one, and then the UP irrigation department is going to basically implement this, and this will come into the existence in a couple of months. So just now we have finalized this the wetland here, which includes some kind of the given structures, and also it includes like a phytoremediation the strategy, and of course we also have some kind of the physical unit for the oxidation ponds here. So there are different oxidation ponds stretches have been identified, the different stretches for the constructed wetlands, and we have here both the vertical and the horizontal flow for the wetlands, and then you will be getting some kind of the relief from the pollutant load in that drain, which is the main drain in the Noida. The another thing which concern of the stream aquifer interaction, which basically controls the exchange of the the contaminant and the flow both, and that is what has to be looked into, because you will be having interaction with the shallow aquifers, and whether you are contaminating or you are removing through some kind of the bank infiltration or some kind of the the phytoremediation, that has to be looked. So this aspect is also an important for any drain, especially which is online, and that is what happens in most of the cases in the natural channel. So with this concept, I'll be showing you here a couple of more slides that will focus on that in case of the degraded rivers, and when you have the re-aeration, how you can scientifically analyze and model. And that is what I can show you here. See the spatial variation in the water quality parameters for River Yamuna. This is the case study for Yamuna. So this is the location at Wazirabad, ITO Bridge, Nizamuddin and Okla Barrage, and you can see the variation of DO here, the variation of BOD in different time from 2006 to 2010. In this time, the total here, the K nitrogen, the ammonia, and what we did, we tried to identify the stretches here, that what kind of the stretches can be grouped or clustered based on the statistical analysis. So this is what we did the clustered analysis here, and then we identified in the first group, which is more or less the living river system. That means the DO is still more than 5 milligram per liter. So there we get a cluster of this kind, and we see that the TKN and you see the DO or the ammonia and BOD, they are making a cluster here, and similarly here the different clusters are being formed.
Professor, please summarize a little early.
Yes, sure. I'll take a couple of more minutes, that's all. Yeah. So clustering at the polluted stretches, you can see it here how the groupings are being done for the ammonia, nitrogen, BOD, water table, DO, pH, and COD. And based on this clustering, we identify that really which parameters are dominant, which should be taken into the re-aeration analysis or developing the re-aeration model for a degraded river. And this is what you can see the variation here, the estimated K2, and here the observed K2 by various predictive models I have listed out here, and you can see the total random phenomena you observe, and none of those methods really work well. And if we see in terms of the error, you can I have just grouped some of the models here which are giving the lowest error, and some are here you are seeing, and how the correlation you are observing by making use of these predictive models. So this is what it gave a thought that we should have a new model, and we try to develop a model based on the neural network and fuzzy interface, and this is how we have gone for different configuration and of the ANFIS models. And then we observe that this is what you can see, the ANFIS 8, 6, and 10, or ANFIS 6 and 8 are giving the best results for the re-aeration. So why I'm talking about the scientifically modeling the re-aeration, because what you put the technology, or what we put the processes there, that helps you to understand really how much those system, whatever you have implemented, is performing well. So this is what the correlation you can observe for the observed and predicted re-aeration coefficients. You can see it here, the output for different models. So these are just another 5 and 6. So in a nutshell, what I mean to say that when you put a system of different complementary technology, as I have said it here, involving some process intervention, some technology intervention, or some operational, and then you need to, when you implement this kind of thing, then you have to see also that the really what was the reaeration of those rivers before the project and after the project, and you can evaluate in the degraded or in the healthy rivers by making use of right models for this. So with this, I would like to conclude that the domestic and industrial wastewater find some pathways to join rivers and contaminate them. So that is what we see in Varuna and Assi also. There is a low flow, especially in the non-monsoon time. The low flow and the waste load allocation are of major concern. And another thing here also, highly fluctuating flow. Sometimes that monsoon very low, non-monsoon very low, and monsoon very high. So that affect the reaeration process and certainly the river, thereby river health. We need to have some the kind of the emerging models or innovative models, for evolving some management plans for such kind of river to rejuvenate, and so that you are able to assess scientifically the reaeration for the degraded and reaeration for the healthy rivers. We need to see here that the flow velocity and slope of the stream are the primary hydraulic parameters that govern, whereas the BOD, ammonia, COD, and conductivity are dynamic water quality parameters that basically affect the processes in the long run. And that is where you need to see that how these contaminants have to be removed. And as we have seen, the ANFIS model of this kind works well. So river restoration programs that can be designed keeping in view of the combination of complementing strategies, the waste load allocation, the flow augmentation, the interceptor of drains, the artificial reaeration, which becomes important here, and of course the constructed wetlands, as I have told you that we have recently constructed on the Noida main drain, and that is expected to perform very well. So with this, I would like to thank all of you for patience hearing. So if you have any question, I'll be happy to answer you. Thank you very much.
Thank you. Thank you, Professor Kesri, for a very, very nice lecture and your thoughts about the river Varuna. So as far as this session is concerned, I think we have already covered all the speakers, and I would request Professor Raghav to summarize and give an opportunity for discussion if time allows us.
I believe there is no time now
for discussions.
Because 2:30 is Professor Singh here.
Professor Verma,
yes, sir.
Did we hear something from Professor Rai's group? And Professor UN Rai, you are here now.
Yes, we did not.
Professor Rai, would you like to say something?
Professor
Yes.
UN Rai, are you here?
Actually, it is too late, but I would like to say something.
I mean, maybe even 2-3 minutes, please. I mean, speak your mind and whatever group suggestions you have to offer. So before we finally conclude, yes, please.
Good afternoon. At the outset, I would like to thank Professor Singh, who is convener of this conference, to provide me an opportunity to interact with you people on river health assessment and restoration. Actually, I would like to talk in two parts. First part will be our plan of work on river Assi. Actually, we have created a group on the revival of Assi River, in which we have conducted 6-7 seminars, and hence in this backdrop and the inputs provided by the stakeholders in this conference also, we have identified some points which is of varied kinds, besides the task which Professor Singh has given me to identify the sites for the phytoremediation or bioremediation in Assi catchment or in the river itself. So as you could see that Assi River is facing variety of problems. So multifarious action is involved to revive this river. Uh, so first point is survey level GPS mapping of the entire course of river, because it has been now established that it has originated from Prayagraj to Varanasi. So it should be properly done by the government department, and it will be easier also for the government to undertake the channelization job, and the we citizen group can push it. However, we have started. Let us start first dislodge the 8 kilometer length which is in Varanasi, and clean its flow line, prevent the solid waste dumping into it with the help of Varanasi Municipal Corporation. And second is ecosystem and nature-based solution to study ecosystem services, socio-economic status, local plantation with native phytoremediator plants, and development of wetlands, which may be of different kinds: surface, subsurface, horizontal, and vertical wetlands. We also propose to develop planted lateral canal all along the Assi river course, and also install the floating wetlands, because the water flow is very much high in this river, and developing a suitable river catchment area, which is most important in the light of the degrading paleo channels, and to study the groundwater and aquifer recharging available with the modern technology, and segregated collection of used water from kitchen. Actually, the government has intercepting the different water sources which is going into the Assi river, but we propose that we should check the pollution at the level of source. So the used water from kitchen, bathroom, washing machine, initially from the individual houses for on-site treatment, and using waste heat and solar heat as energy source, and recycling using engineering and biological solutions, which will reclaiming the Assi River. And our most important point is to design and develop a decentralized human excreta management system for the maximum nutrient recovery, of more effective sharing and consolidation. Use of night soil and urine as a resource for chemicals, biofertilizer, microbes, and potential enzymes. Unit operation is also possible for hygienic collection and transportation with social acceptability. And as invest in this conference, also the development of a stagnant water pond for in situ bioremediation, phytoremediation, and oxygenation on the available land, may be near the Sankat Mochan. Installation of solar smart microgrids along the drains of the river, and hydrologically domestic wastewater and the rainwater after the in situ treatment will be also codified into the river. Revival of ponds and tanks also along the paleo channels of the river to augment base flow and environmental flow from the river Assi is highly required. So you can see there are a variety of problems, but let us start the beginning, and I'm sure with joining hands together we can contribute to the river Assi and ultimately to the Mother Ganga, which will preserve the cultural heritage of our holy city Varanasi. Now I will, second part, which has been the task assigned by Professor P.K. Singh, I would like to So this is the task which has been assigned by Professor Singh regarding the identification of sites, including ponds and rivers in the Assi catchment for the bioremediation and phytoremediation of contaminants. So I will not tell much about the what is the constructed wetland technology, what is phytoremediation, but this slide shows you three types of the constructed wetland: surface flow constructed wetland, subsurface, and the vertical flow constructed wetland. Actually, these are the 3-4 types of the wetlands which are being selected based on the topography of the area, nature of the effluent, and the demographic factors. This is a picture just to show you. We have developed a constructed wetland at Haridwar.
We are unable to
treat the domestic waste emitting from a religious organization, Shanti Kund.
Dr. Roy?
So you can see there is a pond, settling pond, in which we retain the water for at least 24 hours. Here the coarse material is settled down, and also we have introduced in this some bacterial consortium which is playing role in the degradation of organic matter.
Dr. Rai, we can't see any slides.
4 hours we pass into, I will not go into the detail, I am coming to the point. This is the outlet and this is the inlet, and we have to maintain a nursery of the plants because the plants are loaded with the pollutants, so we have to remove and replant. So you can see these are the results of the wetland we developed at Shanti Kund. You can see how much % removal of these parameters, and there is improvement in the water quality parameters. So now I'm coming to the eco-technological interventions to revive the Assi River. In this, we have to study the feasibility of revival of paleo channels, and a good catchment area is required, which will ultimately provide water to the river through underground recharging. Revival of ponds and tanks are very much required. Augmentation of base flow of the river through reused and reclaimed water in Assi River and its catchment. And there is a canal from the Ganga Gyanpur pump canal. We can also augment this water into the river Assi through this pump canal. Groundwater recharging by rainwater in rainwater harvesting system and aquifer recharging. These works we have to do in the catchment of the river Assi, which ultimately will help the revival of Assi River. The student of Professor Singh, RHAR, has already described all these 3 STP. But why I have mentioned here that we can reuse this reclaimed water in the Assi catchment for the water recharging, and we can also fortify into the river Assi. One thing I would like to say here, there was a dream of Pandit Madan Mohan Malvi that the Ganga water should flow into the BHU campus, especially in the Kashi Vishwanath temple, which is in the middle of. For that, there are canals also, but only we have to push the Ganga water into that, and that water can also be used for the augmentation of water in the Assi River. And these are the possible sites for the bioremediation and phytoremediation of the different things. You see, actually, in STP, all these 3 STP, the wastewater is being treated, but it is not up to the mark. So I would like to suggest here that at tertiary level, we should renovate this STP treated water with constructed wetland. And the fourth is we can develop a constructed wetland by making a stagnant water pond in the near the Sankat Mochan Mandir. where Professor P.K. Singh has also proposed to develop a ghat where we can take bath, and the lateral canal system, plantation of phytoremediator plants from uh, from Ravindrapuri Bridge to Ganga confluence, and second from Khandawa Pond where this Assi River originates to Mahila PG College, we can make plantation of the river bank. And beside, apart from that, free floating wetlands, because the water current, although it contains the sewage and other waste water, but the current of the river is very high. So we have identified or proposed 10 locations depending upon the water current to develop floating wetlands. We have to take something in which we will plant the rooted plants, and they will put into the river Assi. And lastly, I would like to thank you all for your valuable time. Thank you.
Thank you, Dr. Rai, for your nice thoughts and very good solutions, which may definitely be considered by Professor Singh while making his report. So, Professor Raghav, is it time to say goodbye or?
Yeah, I think so. I mean, basically the next session would be starting very soon.
Yes. And we have not yet taken lunch.
Yes.
So, Professor Singh? So, Professor Singh has requested all the speakers and participants of this session particularly to prepare a page or two note on their thoughts and suggestions for River Assi and River Varuna. So I, on behalf of Professor Singh, would like to request all our esteemed delegates and experts to give their thoughts. Dr. Rai has already given very in-depth solution and his thinking, but a write-up to Dr. Singh would be more useful. So, Professor Verma, we can say thanks to everybody.
Thank you. Thank you. And let's meet for the valedictory session. Professor Singh has already sent the link. So thank you very much for your time and patience.
Thank you. Thank you.
Thank you very much.
Thank you, sir. Thank you.
Thank you. Thank you.
Dr. Jha, would you like to say something? Jha Sahab?
requesting everyone to join the main link. It is the link is given in the message box. Sir, with your permission, I am requesting everyone to join the link which is given in the message box. This is the link for last session, recommendation for way forwards and valedictory session also. Please join that link. शेड्यूल सर के पास है, सर के पास है, सर के पास हम खुद देके आए हैं कुछ देर पहले।
एक ही तरह से